Let's spend some time today talking about acceleration. Who wants to volunteer? What does acceleration mean? Increasing in speed or something. Could it be a decrease in speed? That's deceleration. What if, okay, here, I'll pull up the class, hopefully from the where it always is. Yay, it's still here. I gotta be careful, I'm extra careful with the cups, because if you hit my head, I'm gonna be close. Be careful with your head. I got a rubber stopper on a string here, and it's going at a pretty even pace. Is it accelerating? Like if I maintain that pace, not accelerating. What's the formula for acceleration? Anybody know? It's going to come up on the slides here eventually. No? Does it have something to do with changing speed, Jen? Okay. Is it speed or is it velocity? Or does it matter? Don't know? Okay, well, we're going to answer all those questions today. I'm going to ask you all those questions kind of at the end. We'll start you off with an easy one. Start you off with an easy one. You're all familiar with the Grinch? And no, I don't mean Mr. Michael. Mr. Ralph. Yeah, someone yelled it out. Oh! Correct answer? Max. Now the reason that I start off with that is because I remember when the kids were little, we watched The Grinch every night right around Christmas time. You guys probably watch a lot too, right? And there's this scene in The Grinch, and I gotta start crying on YouTube now, but there's a scene in The Grinch where Max is supposed to be the reindeer. He doesn't have the horns on there, right? But he's going down the hill, and the Grinch goes so fast that he actually catches him, and the dog goes up and around and back like this, right? And I always thought it was the physics whenever we watched that. I thought, yeah, that couldn't happen. So it always reminds me of that. So I throw that up there just as sort of a little reminder. Yeah. Okay. So let's. Oh, geez. I think I gave you I think I've got the answer right there, don't I? Did you have a question 2? Did it ask you for question 2? No? Oh, no, it didn't. Okay, never mind. How am I going to do this here? I know. No? Yeah, because I pressed start and stop. It's okay. Don't worry. You guys worry too much. Okay. Question number 2. By the way, you're going to have to write some of this down. Right. You should write some of this down. This is kind of, we're doing notes here. Jot down the important things. Again, don't get fired up about writing everything down. Write down what's important. Acceleration is, like velocity, is it a vector or is it a scalar quantity? Yeah, the correct answer is A, vector. Acceleration is a vector quantity. Some people got it wrong, so make sure you get it right in the notes, right? So because it's a vector quantity, that means it has a size, it has a number, and it has a direction. Okay. Even pace, acceleration, or no acceleration? Dan still says no acceleration.
Oh, because you're changing the direction it's going. Does that count as acceleration? Because you're changing the direction?
Dan is not saying what you should. Dan is now saying because when I'm changing the direction, he's saying, does that count? What do you think? Brandon, what do you think? No? Reese? Maybe? Acceleration is a vector, which means it has a direction. Okay, here's another harder question. Don't hit your head. Let me switch to this next one. What's the direction of the acceleration? Sort of, in a way. Okay, we'll leave it at that. We'll keep coming back to it. Man, I hate it when that's. Question number 3. Acceleration can be positive, which is? Which way? Positive? I heard someone say something over here. Try and see. Acceleration, we're still talking acceleration here. It can be positive acceleration, which means to the left, to the right, to the up, to the down. It may not be grammatically correct, but don't worry about that. That's not a reason to be. Yeah, B and C, those people that thought it might be Q are correct. To the right and to the up. Positive acceleration up. You probably should get question number 4 right? Negative acceleration. Negative acceleration to the left, to the right, to the up, to the down. Yeah, come on. Okay, does that mean everyone got it? Or it means some people didn't answer D? Some people didn't answer D, but the correct answer is yes, left and down. If I drop the rubber stopper, gravity is taking it down. Is gravity causing the acceleration? Yeah. Okay. Does deceleration always mean slowing down? Yes or no? Oh, you can't have Canadians on Jeopardy. Does deceleration always mean slowing down? It's easy to guess. Yes or no? It's okay if you don't know. That's why we're here to learn something. Deceleration always means slowing down. Oh, quit worrying about the average. Not necessarily. Now I need to clarify this here. Here's where you put the clickers down and here's where you listen. Okay? In the fine print it says, acceleration to the left. Dan said earlier, negative acceleration. He said, no, that's deceleration, right? Acceleration to the left, sometimes called deceleration, right? Like negative acceleration, sometimes called deceleration. But be careful, it does not always mean slowing down. How can acceleration to the left not mean slowing down? No, if you're standing still, you're not accelerating. What if you're already moving left? What if I start over here, right? And I'm moving to your left, and then I accelerate. I didn't slow down until I got to the end. That's because I didn't want to run into the wall. Okay? If you're already moving left and there's negative acceleration, then in fact you're going to speed up. Now, is that deceleration? Okay. The whole point of this little conversation right here is don't use the word deceleration in the class. I won't use it past this slide right here. Okay? Deceleration out there in the real world means slowing down. Okay, I get that. But in here, we don't use deceleration because I try not to anyways. I might slip up. But I try not to. I try to say negative acceleration. And I want you to know that negative acceleration doesn't necessarily mean slowing down. Okay? Negative acceleration just could mean to the left or to the down. And if you're already moving left or down, it's going to mean actually speeding up. Okay. What does like acceleration really mean? Like, if I've got an acceleration of -2 meters per second squared, we'll talk about those units of it. You know, let's just make it simpler. Let's make it to the right. Let's say I have an acceleration of 2 meters per second squared. What does that mean? Like, how do you describe that? What does that mean?
Every second he's going 2 meters per second faster.
Every second he's going 2 meters per second faster. Is that, yeah? Ian, you good with that? Yeah? You're just saying that. Yeah, I know, I can tell. Every second it's going, how much? 2 meters per second faster. So if you started at rest, if you started at 0, after a second you'd be going 2, and then Megan, another second you'd be going 4, and another second you'd be going. That's what acceleration is. Acceleration is, if you want to write something down, if you're feeling nervous because you haven't written anything down yet, acceleration is, the fancy definition is, the time rate of change in velocity. That's what textbooks say. Time rate change of velocity. Don't you dare write that on the test. I'm not even sure I know what that means. I know what acceleration is. Time rate of change in velocity. Not the best definition. Science definition. Let's talk regular person definition. I've got it in fine print here for you. Is this better? How fast an object's velocity is changing. Does that make more sense to you? How fast an object's velocity is changing. Or if you prefer, how fast is an object's velocity increasing or decreasing? How fast the velocity is changing. The velocity is changing. Oh, I wish I'd been recording that. It was really good. Good thing everyone's here. Okay. Now, based on everything we've talked about, do you remember now, maybe from grade 10, I don't know, it depends on how far your teacher went with you. But even if you didn't go there, you might be able to figure it out. What is the equation for acceleration? Is it delta d over delta t? Is it d bar over delta t? Is it v bar over delta t? Or is it delta v over delta t? Ooh. Tough one. Tough one. Here's one that you probably want to wait for the answer before you write it down, right? The correct. Okay, what's the answer? Oh, mixed bag. But the correct answer is D. It is change in velocity divided by change in time. I told you this, right? It's the time rate of change in velocity. It's delta V over delta T. Change in velocity over change in time. How fast your velocity changes. Jot that down. Acceleration is change in velocity over change in time. Ready to put your notes on your phone today or what? Or brain? Oh, okay. Maybe you're doing some calculations. Oh, yeah. Or twiddling your thumbs. Sometimes I think students just put their hands down underneath the table and just do this just to tease us. Or maybe just to have it. Acceleration is change in velocity over change in time. Good? Good? Oh. All right, now, oh, that's right. Now, I usually, quite often, did I do it? Say that you did it, then. Did you do it, or did you not do it? I usually print off the graphs for you guys to have. I did. Okay. What I normally do is I print off these graphs so that I can hand them out to you. So don't write that graph down. Okay, so if you want, you can just like label on these graphs. If you want to put in some notes, see figure 1. Okay, so graph 1, right there in the corner, you do what you want, put it in your notes, whatever works best for you, label it, cut it out, whatever, I don't care. Draw it. In the graph below, the displacement graph is a curved line. Now we've seen these already, right? We've seen displacement graphs that are curved. What does it mean? It means that the velocity is, oh, you guys have already answered. Well, almost. What does it mean? Is the velocity increasing, decreasing, or staying the same? Please be right, please be right, please be right. Pretty much everyone. The velocity is increasing. Increasing velocity. You can write it right on the graph. I don't care. Make a note. Would you agree that the slope is changing? Is the slope increasing or decreasing, Alex? Increasing. Right? Here's the slope right here. Here's the slope right there. There's the slope right there. It is increasing. Would that be a graph of Dan on his dirt bike speeding up or slowing down? Speeding up. And eventually, when he reaches top end, the line is going to be what? Straight, constant slope. Okay, now, brand new concept I'm introducing here. Brand new. Since the velocity, pay attention because you're going to need to listen to the intro. Josh, listen. Since the velocity increases at a constant rate, velocity is increasing at a constant rate, the velocity graph is going to be what kind of line? Is it going to be flat? Is it going to be increasing straight or decreasing straight? The velocity graph, the graph of velocities. Did I press start? The graph of velocities. Is it going to be flat? Is it going to be increasing straight or is it going to be decreasing straight? This graph here is, this is a position time or dt graph, displacement time. Velocity time. Velocity time. Feel a little pressure? This is going to be a thinking one. Mixed bag? We'll see. Correct. The majority of you said B, increasing straight. The velocity is increasing, right? It's increasing at a constant rate. Now, geniuses out there, what's the slope of that line represent? Remember how way back at the start I've been harping about how the slope of lines has some meaning. We already know. Hold on, Dan. we already know that the slope of the dt graph, right? The slope m is equal to the velocity. So if I've got a velocity time graph, what's the slope equal to? Go ahead, Dan. Acceleration. The slope of the vt graph is acceleration. I'll say it again so Josh can hear me. The slope of the vt graph is acceleration. Go ahead, there's the follow-up question that everyone always asks. There's always someone in the class. Come on, waiting. Follow-up question. The slope of the dt graph is velocity. The slope of the velocity graph is acceleration. What's the slope of an acceleration time graph? It's called, John, do you remember? The slope of the acceleration time graph. Tough one, man. Yeah, I only mentioned it once. Yeah, I know. Okay. It's called the jerk. What is it called? The jerk. Jerk is a quantity, right? If someone is driving with my father-in-law, you'll know what I'm talking about. Because Gino likes to accelerate, brake every time there's like a squirrel anywhere, right? Very jerky, right? It's how much your acceleration changes. No one likes that. I shouldn't say that with my father-in-law. Is this recorded? Uh-oh. It's okay, he won't be listening to it. Yeah, I'm pretty sure. He's got way better things to do than listen to physics lectures, that's for sure. Okay, so because the velocity time graph was increasing in a straight line, the acceleration graph is a graph of the slope of the velocity time graph. Highlight that, put a star beside it, that is important. The acceleration graph is a graph of the slope of the VT graph. The slope of this graph is 0.4. If I found the slope of this graph to be 0.4, the slope of that VT graph, the corresponding VT graph, then the acceleration time graph would be a flat line at what location? At 0.4. And it means that the acceleration is a constant 0.4, right? You take your automatic transmission, you put your foot on the gas, it's going to accelerate at a constant, without the shifting. Okay, right? This is called uniformly accelerated motion. Uniformly accelerated motion. What does uniform mean? The same. When the basketball team hits the court, they wear their uniforms, so they all look the same. Unless you're the JV team that one year where we have a competitive uniforms. When I take the tennis ball, I'll wait. You guys finish. I'll wait. Got to keep an eye on time. I apologize for the big long class of me talking. I try not to do it. You know what? I like to say physics notes are like bananas. You know why? Because they come in bunches. It's a good one, eh, Brody? That'll get me an award or two for worst joke ever. Okay. When I drop the tennis ball, does it speed up? It does. What's the acceleration? Anyone know? Anyone know what the number is for gravity? On the moon, it's 3.6. No, it's not 1.6. Anyone know? 9.8. It speeds up at 9.8 meters per second squared. Is it uniform? Because whether it's here, or over there, or in Sifton, or in Winnipeg, or Melbourne, Australia, the gravity is minus 9.8. Sort of. There's variations, depending on how high you are, and but for the most part. Okay, it's uniform accelerated motion. Okay. Okay, now do you have this graph on your page? The one that I handed out. All right. Now, this is sort of the introduction to velocity time graphs. It's a whole new way of thinking. Okay? This velocity time graph right here is an example of what we call variable acceleration. It doesn't happen a whole lot. You don't see it a whole lot. Variable acceleration. The acceleration is not constant, constant, or it could be constant or not. If you think carefully, you should be able to get it. Pretty easy. Velocity time graph is an example of variable acceleration. Here the acceleration is not constant, constant, could be constant or not. Which one is it? At the very least, you should know that variable acceleration is whatever the answer here is, right? Go ahead. Yes, not constant. Not constant, because this is a velocity time graph, so the slope is acceleration. Is the slope always the same? No, the slope is not always the same. This is called variable acceleration, is not constant. Right? It's jerky. Not the beef kind. Okay, now, here's the thinker for the day. Does this object in this graph ever move backwards? Yes or no? Does this object ever move backwards? Yes or no? Whoa, 50-50 split. Uh-oh. Dan must have got it right based on his reaction. So the correct answer is no. No, it does not move backwards. How come? Who can explain why? Go ahead, Morgan. It is the speed. Okay, you're right. Is there another way to put that? The velocity is right. Always positive. The velocity is always above. It's always positive. Positive velocity means moving to the right. It never goes into negative velocity territory. So what is indeed happening from A to B, Morgan? It's still moving forward, but it's slowing down. It's slowing down. It's like I start here, right? And I speed up, and then I slow down, and then I speed up again, right? But I always move forward. Make sense, Taylor? Yeah? What would it look like, Brody, if it did move backwards? What would the graph have to do for it to go backwards? It would have to drop below. Right, Megan? Hello, ladies. And Alex and Josh. You guys got to keep listening. I know it's hard to listen to me for this all this time. For it to go backwards, it would actually have to drop below. Go ahead, draw it now. I told you how to do it. I just told you how to do it. If you're listening. Draw a velocity time graph with a similar shape that shows the object moving backwards. You're drawing a velocity time graph that shows something with the same kind of shape, but eventually going backwards. If you're paying attention, it's about an 8-second job.
Yeah.
You want to come up and draw on my fancy screen here, Josh? You're good? Like that, right? It's got to be below. Below. Velocity negative. Okay, smart guys and girls. What's it doing speed-wise here? Going backwards, but is it speeding up or is it slowing down? Speeding up, backwards? Slowing down, says Andy. Tell me, what do you say? Is it speeding up or slowing down, going backwards? Right here. It's a tough one. What's the slope doing? Listen, you guys. Listen, we're still learning here. What's the slope doing? Getting steeper or flatter? Flatter, so that means it's slowing down. Slowing down. Okay, I got to pick up the pace to get done here. Notice that the slope of the curve is not always positive. Between points A and B here, you could draw this right up on that shape, that's on that graph that I gave you. Page. Between points A and B, what's delta V equal to? Alex, put the phone away, man. We're still learning here. Listen, man. You guys got to be able to get through a 45-minute class without. You got to listen. Okay? You're not going to hack it at university. You can't do that. You can't take 30-second breaks every 2 minutes. You got to stay with the old dude at the start, at the front of the class. Delta V is minus 2. How come? Starts at 4. Well, it's close to 2, right? It goes from 4 to 2. The delta V is 2. The time is 3 seconds. 4, 5, 6, 7. What's the acceleration going to be during this time? The slope of that line. How do you find slope? Rise over run. 2 minus 4 all over 7 minus 4 minus. The acceleration, the average acceleration during that time between A and B is minus 0.67. Every second, the speed is decreasing by.
Should there be a bar over the gate?
There should be, Dan, actually, you're right. There should be a bar. Okay? I've thrown a lot of stuff at you today. All this stuff is coming back in the next week or so. Okay? Don't worry if you don't get it right now. It's coming back at you. Okay? But at the end of today, you need to have a general understanding of what acceleration is. It's a change in velocity. If you know that, when you walk out today, you're good. Acceleration is a change in velocity. Good? Thanks, Megan. Anyone else? Good? Okay. Let's talk a little bit about units here. I'm going to wrap up a bit early because it's been a long class for all of us. I get it. I'll wrap up a bit early. I'm not going to go right till 10:03. Notice the units on the acceleration. They are meters per second squared. Why? Acceleration is the rate of change of the velocity, which is the rate of change of displacement. Okay? Now, acceleration. Just watch. I'll give you a chance to write it down in a second. Okay, pencils down. Just watch. I'll stop talking in about 30 seconds. Acceleration is change in velocity over change in time, but change in velocity can be rewritten as change in position, delta D over delta T. So it's delta D over T over T. D over T over T, right? Now if you use units, yeah, I know. I always hear that. Every time I look through that, I always hear it. Watch carefully. D over T is going to be meters per second divided by seconds. Now think back to Mackenzie, junior high fractions. Meters per second divided by seconds, which is seconds over 1. Do you remember how to divide fractions? No. You flip, you invert, and multiply, right? So we're going to invert that seconds over 1. We're going to have 1 over seconds, and then when you multiply fractions, you multiply the tops. Meters times 1 is meters. Seconds times seconds is meters per second squared. This, my friends, is called dimensional analysis. Big, crazy, giant word. Professor dudes use it to figure out like what the units should be, right? It's basically taking units and doing canceling and stuff like that. I don't expect you to know that, okay? That's just the advanced kind of thing. Some of you might get it, some of you might not. It's all alright. Okay? But I wanted to show you where the units for acceleration, meters per second squared, come from. What am I going to hold you accountable to? When you write acceleration is 4 meters per second, well, that tells me you don't really get acceleration because you think it's a speed. It's 4 meters per second squared. I got to see the squared. That's what I'm going to hold you accountable to. Okay? Acceleration is not in meters per second, it's meters per second squared. Alrighty? I just want to do another check ahead here. I'm going to come back to this. I just want to see how much more I have to go. Okay, all right. Okay. Is that true? Acceleration is some change in velocity. It could be a change in speed or it could be a change in direction. That's what you got to know from today. Am I going to ask you to define that? No, I'm going to ask a bunch of questions designed to see if you get that. Yeah, return the clickers and then we'll watch the video. Please watch this. It's 4 minutes long. Put the phones down. 4 minutes takes me to 9:58. I'm going to give you the last 8 minutes of class to do whatever you need to. Put the phones down. Watch this.